Well, all too often it seems leaders grab onto the notion that performance would just be better if they could do all or some of the work in an offsite, more controlled location. And this raises some really interesting questions like what to move offsite, where to do the work, how to prefab or preassemble, that if by left unaddressed often results in some pretty disappointing results. Well, our next presenter, Todd Zabel, who hardly needs any introduction, has tackled these issues in the next paper, How to Lay Out Plants and Shops in Support of Industrialized Construction. So, Todd, welcome. Todd is the author of Built to Fail that I mentioned earlier. And he's also the founder and president of Strategic Project Solutions and the founder of the Project Production Institute. Prior to that, Todd founded Pacific Contracting, which was recognized in the mid-90s for its use of various innovations, including lean construction and virtual design and construction. Over the past 2 decades, Todd has authored numerous papers on the topic of optimizing engineering, fabrication, and construction. These papers have been published in various technical journals, presented at numerous conferences around the world, and there's no person better qualified to present this topic than Todd. So, Todd, I'll turn it over to you.
Well, thanks, Gary. This is part for some friends out there that seem to call us every once in a while and say, hey, I'm going to go move my work off site. I think you know something about that. Can you assist me? We're going to show some things today that might be a little bit not totally clear when it comes to the slides, because we don't want to show all the secrets of what people are doing out there. But definitely, we're going to tell a story and give some insight that people can action right away. I think the bottom line is there's a lot of interest and investment in moving work off site. This really started, I remember, in the late 90s in the UK. And of course, this is very popular amongst the oil and gas sector because it's hard to build a offshore platform out at sea. But for most of the people that are getting involved in this, the results are not what they should or could be. And the question's being asked, how do we make this work? I heard something earlier that's been a common theme, and that is we seem to be able to take some time out, but the cost is not being impacted. And we've heard the cost we could reduce, but we can't get the time out. And there's some reasons for that rooted in operation science. Basically, what we're dealing with here are some blind spots in how to think about all this. And if you take anything away from today, is at least understanding these blind spots. But first off, what we're seeing are people don't really understand what business they're getting into. And we're going to spend a couple minutes on that. There's lack of understanding of the customer demand profile and associated demand variability that impacts these things. So it's a good idea. We're going to go set up a shop. But does our company have adequate demand to support a shop? Do we need other customers? And if we only have what we've learned through the years in the way of reliability or commitment reliability, we might want to call it on a construction side of 50% per day, how do we deal with that in a shop? All right. That creates the inability to match capacity with demand. So either we have too little or we have too much, or it's not available when needed. This is a big one, wrong facility in the wrong location. Freight terminals seem to be the solution du jour. People love taking over freight terminals. I'm not certain why, but that is one that many look to. We end up with columns interrupting layout and flow, electrical in the wrong place, logistical constraints. This is really something that's going on there where we start off with getting a facility, and wouldn't it be great if the facility was close to the house, right? Equipment totally not well suited for the situation. The sales guys are eager to sell us stuff that can do all sorts of wonderful things. We may or may not need them, but it's basically a nice new machine, and maybe we need to get one. Lack of understanding of basic operation science. Speaking for people that I work with on the factory physics side, even, we've been blown away how this is even pervasive in the manufacturing sector. But there is a science to how you design production systems, and there's methods of modeling and tools that you could use to do that and should use that. And then, of course, there's insufficient or lack of effective means of production control. And we'll touch on that, but this is a little bit less about that. But there's an implication on production control and this idea of WIP. So there are some blind spots out there, and that's causing some issues for people. The first thing, though, and it's worth to spend a couple minutes on this, is really asking the question, what business are we getting into? For the most part, construction at its front lines, whether it's in design, engineering, or fabrication and construction, is a service-based business. There's a low initial capital investment. All right. Utilization and capacity is the priority. And the business model is based on a cost plus the profit equals the price. As you move through and from maybe construction and design, integration, and fabrication down into the world of manufacturing, all right, the financial model changes, right? The market sets the price. What your cost is equals your profit. You become concerned with inventory. You keep hearing on these PPI sessions about WIP, work in process. That is definitely a concern. And you have high initial costs. When you're going to build a plant, there is definitely high initial costs, right? So the things change, and you have to be clear, what are we actually going to go do? All right, what business are we getting into? If you're used to getting paid for technical development or engineering, that may not happen if you get into the manufacturing sector. Typically, you're not paying to have them design your car, okay? It's all part of the price. So one question is, what business are we getting into? Operations, science, relationships. I'm not going to spend any time on this. There'll be more discussion as the day goes on. If you're on this session or in the session, you probably know what this is about. But what we're going to talk about is how to apply this and how this can be used to determine how to lay out a facility. So what are the implications of not knowing what business we're getting into, getting sites that are close to our house, that are freight terminals, and so on and so forth, right? We get excessive costs and use of cash, all right? And that has to do with this idea of build up a WIP and unused capacity that I think was talked about even a little bit earlier, right? Frustrated customers due to unreliability and long lead times. So lead time is a service level. As we try to optimize and control to meet our profitability objectives in the shop, we may be causing challenges for our customers who might actually be in the same company, right? Who might be serving a site in the case of what a lot of mechanical electrical contractors do, or cladding contractors. So what happens is people tap out or go out. Clearly, Katera was probably the biggest one to go out, but others have tapped out and said, I just can't make it work. And that results in resources being squandered and reputation damage. I think there's going to be a lot of people here that'll be tapping out soon because they just can't figure out how to make this work. And that's unfortunate because there is a way to do it. So our proposal really is that there's a better way, and to look at the layout and the design of a offsite fabrication facility, just like you would any other facility, and use a simple process that could be exploded, but start off with defining what it is we're trying to do, then moving to design, deploying it, and then effectively controlling it. All right. This should be very familiar to everybody. And let's make sure that the control has a feedback loop into the design so that we basically, as we go, we're getting the data to create a digital twin. All right. So we're opening up the kimono here, and we're laying out some of the voodoo that we use for the betterment of the industry. And we ask people to respect this. But basically, these are the questions that, and not all the questions, but the majority of questions that need to be asked when we're going to go set up an offsite fabrication facility or even a high volume manufacturing plant. We need to go through and ask a series of things that define what it is about that we're about to design. You know, basically what's going to flow through the production system. Are these things made to stock or made to order? What is the associated value chain? Because production systems don't represent the whole value chain. They represent part of the value chain. So what part do we need to play in the value chain? What's the resulting production system from that portion of the value chain we're going to play in? What are the boundaries? What do we need to understand? We probably need to have a pretty good handle if we're going to move site from a construction site into a fab shop. We probably need to have a pretty good handle on how the site's behaving, whether we want to be part of that or not. It's going to impact what we're doing. All right. So that's part of the boundaries. Supply chain coming in, at what level between assemblies, sub-assemblies do we need to be involved in what's getting delivered to us? What will we insource, right? So there's things that we're going to do in-house, and then what will we purchase and outsource? If we do it in-house, what processes, operations, and associated parameters, equipment, and tooling do we need to do that, right? What's the best combination? If outsourced, we purchase it. How much inventory do we need to hold where? And what's the lead time and fill rate that inventory will be delivered to us? If outsourced, what form of production system, right? Are we dealing with a job shop? that has to do setups? Are we dealing with processing? Maybe it's some kind of fly ash or something. And then how's the supply being provided? How much space will the process and operations inventory require? That's obviously an important question. How much demand will be placed on the production system? Again, going back to the demand being a critical element of this. How will cycle time, uptime, yield, and other parameters influence the design, right? And then what methods and tools will we be used to actually do this, right? So what we're proposing is, and this shouldn't be new to anyone that's involved in engineering or design, is why don't we go through a series of questions, maybe there's more that need to be added to this, and create an actual basis of design, right? So the first step in going off site is to work through a process of creating a basis of design. The basis of design is merely the documentation of important questions that need to be asked, right? So that's number one. And maybe this is an outline of what a basis of design would include, but this is taking the questions and summing them up, right? So what's the purpose and objective of the production system? What's the customer profile? Where are they located? Again, the value chain. Within the value chain, what's the production system scope and its characteristics? Are we going to insource or outsource? How do we analyze that? How do we make that decision? What equipment, tooling, and labor do we need? What are we going to do for the actual design of the production system from the methods and the tools? And then, of course, budget, schedule as part of it. Next step, we move to design. Okay, so now we've got this basis of design. How do we actually go design a production system? Well, we've definitely got to map the defined production system process flow, right? Including equipment and tooling required to do the work. We have to establish that the process centers are standard or fixed. Do we need the thing to move around in the way of some job shops that have to be based on flexibility because different things are being made? And so there's setups at the operations or the process center, then there's setup of the whole shop to go run something else, right? Identify the production system behavior through modeling and simulation analysis, focus on throughput, cycle time, WIP, capacity utilization. Determine where the bottleneck will occur and relocate if needed. This idea of balancing the flow is not a good idea. There's going to be a bottleneck. You should decide where the bottleneck's going to go, and you should control it as a valve or a meter, because the bottleneck rate will tell you what the throughput will be. Size and locate capacity inventory buffers. We know there's going to be capacity inventory buffers that we either need to put them in place or they're going to appear. I'm going to talk a little bit about how that is done through modeling, not through kind of just pulling it out of your ass, for a lack of a better word. Establish production system policies, right? So if we need to control to something, right? So we should be able to walk out there and we should be able to say, look, there should be 5 at this station, 3 at this one, and 8 at that one. We should be able to calculate and see that. And that takes us to designating key performance indicators with associated performance frontiers, designate the method of production control, how we're going to control, identify the facility layout and design. So we've gotten all the way down to number 9 here before we said we better go find a facility. Well, we haven't actually even found a facility. We said this is what the facility should look like, right? Now we go look for it rather than at it. And then design the facility, include the required equipment and tooling. So really all this work occurs before we actually get involved with the facility's layout. And so here's a little bit of a digital representation or graphical representation where we're taking the objectives and KPIs of the production system with the technical process flow, maybe jumbled, may have to change or not, maybe fixed, with the process center parameters, right? Each operation in the process, the demand, what we're not making, okay, which is going to be supplied. And out of that, we're going to create a production system design, ultimately a digital twin. And as part of the production system design, I've broken out, because of the title of this talk, to facilities design. And so how do we do this? All right. There's tools for doing this, including analytical modeling. So the first thing we're going to do is we need to build a flow of the production system, right? And the production system, as we mentioned, might be work that's not done in the shop, and it might include work that's done by the customer outside of the shop, if you will. All right. And from there, we can do analytical modeling to begin to determine the answer to many of those questions. I want to show you that in a sec. We can also use simulation to show us what's going to happen to the shop or the production system, I should say, over time. So let me redact the shop and say the production system. So we want to understand what's the demand, including the variability from the customer, what's the reliability and the fill rate of the supply, and how's that impacting our shop, and what's the behavior of the shop, so that we can get an overall view of this thing on what's going to happen with critical measurements, including throughput and cycle time, and the two levers that we really can control once we're this far down the pike, which is the WIP and the capacity utilization. All right. Now, James is going to talk about this later, and this is very excited, where there's the ability to use analytical modeling with simulation, right? And you're going to see the power of that shortly. But coming back to this, I mean, we're probably to the point now in the conversation where you're saying, well, what does all this tell me and how do we use it in the real world, right? It seems somewhat theoretical. Interesting, everything I'm showing you is real world. It's going to be a little bit jumbled up only because we can't show everything everyone's doing. But it also seems really complicated. And as Roberto always says, it's not what we're showing you is complicated, it's what you're doing is complicated, or should we say complex, right? So there's no easy answer to what you're doing, right? So we agree it is complicated and complex, but not doing it or getting it wrong can result in significant loss, right? And there's a lot of carnage that's going on out there now. So let's take a look at what this might look like, all right? We could take the model of the production system to determine the routing, layout, and resource requirements, and that's what's happening here. Once a production system is modeled, including the parameters associated with each operation, process center, or maybe make a simple step in the process, that data and its behavior, coupled with what is flowing through the production system, right, enables us to do some analysis that's very important into how we're going to set up the production system. Now I'm going to dig into this a little bit more as to what this is about. But items like how many resources do we need, whether it's people or equipment, and how much WIP should we have at any point in time, at any place in time in the production system, is easily calculated. All right. So let's just take the first thing is the flow analysis through the process, or in this particular point, at a given process center in the process. Okay. We could see here the demand line coming across is telling us we need 2.5, right? Based on the production system's behavior, right, we're going to need to set the WIP at a certain level, okay, that tells us where the zone is, where we're going to be able to meet the requirements of the customer service level in the most efficient manner possible. If we have any less WIP than that, we're not going to meet the service level. If we have any more WIP than that, we're going to actually extend time and perhaps not meet the service level for the customer. All right. And we could do that automatically using methods and tools through each step within the process. Okay. So one thing we want to do is set the WIP policy, and we want to use that WIP policy to understand where the overall WIP should be in the process and at each step in the process, if you will, so that we can actually monitor and control what's going on. All right. So we get very detailed here. These are automatic outputs that come out of using modeling and simulation tools to understand exactly what's going to happen. All right. Queue time is of interest. And one of the things that we see is people ignore queue time. If you think of queue time, that is stuff waiting to be worked on. If you take the stuff waiting to be worked on, multiplied by the dimension of the thing waiting to be worked on, okay, and put a little bit of extra space around it, you actually can calculate how much space do we need between one operation and the next. What we're seeing out there are people ignoring the queue time. They're putting the equipment too close together in the shop, and rather than reducing the queue time, it's running wild, and now they're moving stuff outside the shop. The greatest observation I ever made is someone in the steel business who put in a little internal rail car to take the stuff out and put it outside to bring it back in. And what was happening there was a queue time that was excessive associated with how the production system was designed, right? And so what we're looking at here is taking the time elements out of the production system and using that with the geometry of the items to be worked on at whatever state they are in the process to determine the space requirements that we're going to need, okay? So the amount of WIP we have tells us what space we need. If it's inbound stocks, work in process, or finished goods, we need to know how much we're going to have to figure out how much space we need. We haven't gone out to get a facility yet, right? We're just trying to figure out what we might need based on what's going to happen, okay? So again, we can get very detailed resource requirements as to what we need, right? Again, the idea is to have you're going to have a bottleneck, know where that bottleneck is, and control that bottleneck. If this bottleneck's in the right place or not, I don't actually know. I'm not familiar with the case, but I can tell you that this is what it should look like, and that there is a bottleneck to control. All right. Now, again, number of machines, right? So based on the parameters to meet the customer service level, we can begin to understand how many machines do we need and how many people do we need as we start to lay it out. So if I go back here, we see, we see the two-man blast crew, we see the two-man electrician, and here we see that we might need certain equipment, right? And so this is what we're saying is how we calculate the space we need and the equipment that we need, all right? We also want to be able to do financial performance analysis and determine how is all this going to work financially, and is it the way that we like it? Because there is a trade-off between inventory and capacity. Should we have more equipment and more people and more space, or should we have more inventory built up? That may not be a decision if you're in a very much engineered order type business, but if you're in a configured order, all right, you might be able to tweak that a little bit. Okay. So we talked about this a little bit, but the big idea here is by building a production system model, right? And these two aren't related. I'm mix matching some stuff, but just to get the idea. By building the production system model and understanding the raw process time, when things are really being worked on, the queue time, and so on and so forth, we could begin to understand how much space we need. Not only the space to do the work, but the space to hold the work that's waiting to be worked on. We can also figure out what equipment we need. What we should use to figure out not only what space, what equipment we need, and what labor we need, okay? So the design of the production system, again, should have the questions answered and would look much like this, right? What are we going to go do? Facilities delivery still down here. We haven't gone out to get a freight terminal yet. All right. So now once we define and design the facility, we need to deploy it. That's basically the business of most of the people on the session here. It's called construction, and we need to control it. All right. And so at this point, we should be endeavoring to build a digital twin that takes our work from definition and design, puts in a control layer, and allows us to control to those policies and get the feedback loop on the performance data so that we can do what we need to do if things are not in line. It's easier, and that's why they have a assembly line that moves, because they're using that to control the sequence of the work and the WIP. When you move to the world we typically work in, and you're dealing with fabrication shops, the control gets a little bit more difficult because things are moving around a lot. All right. Okay. I'll leave it with that.
All right. Very interesting, Todd. We got some good questions for you. Let me start with this one. I'm going to modify the question a bit. I'm already up to my alligators in an offsite shop. What do I do? Where do I start? Can I apply this to something I've already got launched and have ongoing? What would you recommend?
Yeah, I think that question was actually answered in the previous session, and that is, I think you talked about, Gary, actually the data is available, so it's easier to do, right? So now we're not making any assumptions or taking a vendor equipment data that tells us the machine has a yield of 89 or 99% when it's really 60%, and we think we could weld it in a minute and it takes 5 or whatever. We actually have real data, so it's simpler to do what we would call an optimization versus a design. However, you should still go through the process of definition, defining what are we trying to do here, where do we need to play in the value chain, and then running the same exact stuff that was just laid out. And that, we do this on a routine basis on sorting things out versus designing new things.
All right, next question. Do you have a recommendation for how you choose what your bottleneck should be?
I'm going to let James talk about that one in his session.
Okay, very good. Next one. What software would you recommend to run simulations or models? I currently use Microsoft Visio for process development. Anything off the shelf you would recommend?
Yeah, well, I can only answer and say what we provide at Factory Physics and SPS, right? I think what we got to move beyond here is building Visio diagrams and Excel spreadsheets to try to figure out complex problems that require pretty significant or serious mathematical equations to solve, right? And so I think to figure out a process flow, if I had to just go figure out simple process flow, and I do it all the time, I just use PowerPoint, right? But you got to move that into something where you can do analysis and simulation, and it's just a very complex thing. Again, I think James will bring some light to what happens in the back when we do that.
Yeah, he certainly will. So another question, when you speak of a digital twin, you mean a digital process with feedback loop and modeling and simulation, correct?
Yeah, that's a great question. So one of the things that I really want to do here is bifurcate visualization from analytics and simulation. And so for some reason, we're enamored with visualization, and I have no problem with 4D visualization. We were working on that stuff in the early 90s, hanging out with Martin at Stanford. But what we're talking about here is real-time data feedback as to what's going on in the production system, and having the ability to use modeling, right? And AI is a part of that. Machine learning is a part of that, right? So I would say the three buckets are analytics, simulation, and using machine learning AI to figure out why things are occurring, they're occurring, and how can we optimize them if they're not within the realm of what we want based on our KPIs, based on our objectives.
Yeah, excellent. Just a totally different question. Why do you think people start thinking about this by buying a shop somewhere or a warehouse somewhere?
That's a great question. I think what they see is there's an opportunity to move work offsite or get in the move work offsite business. And the first thing that you really need to do is to have a shop. And since we're in the construction business, we ought to build one. And I don't know why. I think the industrial engineering world has done a very poor job of promoting itself, and it's not well understood. It's probably one of the only fields of engineering where you don't need a license or a certification, right? And so every lean consultant in the world is playing around with industrial engineering, knowingly or unknowingly, right? And so when I set out to write the paper, I started thinking about, I was looking at LinkedIn, all this advice: hire a lean advisor, lower the water to see the rocks, make sure that you protect the bottleneck, map the value stream, make it pull at the what the customer wants. The list goes on and on. I was involved in that stuff early on. I'm not really clear what you go do with that when it comes to getting in the real world of doing the work. You need some mathematics. And so I just think that's, we don't understand what to do with that. The industrial engineering world hasn't done a good job of saying we're important. And so people say, I don't really know what's going on out there. I'll just go get a freight terminal and get going.
Yeah. So I got time for one more question here. Is the shift to offsite, taking workers offsite, the only path to industrialized construction?
Well, I think it depends on who. So if there's one thing that we've got going on, which is, this is a great question. I don't really know who defines the terms. There's debates on what lean is. Now I guess there's a debate on what industrialized construction is going to be. So I don't really know how to answer that question. But if you are going to move work off site, you should be thinking about, how do I take this through a rigorous process of definition, design, deployment, and control? What methods and tools and knowledge sets like operation science are out there? You use operation science every day of your life. The question is, what decisions are you making as you make your decisions and the day goes on. Everybody's using operation science to design their facility.
Yeah.
The question is, are they making the right decisions? Right. So I don't know if this is moving work off site. I really, I'm just trying to explain to people, if you're going to do that, these are the things you better be thinking about.
Yeah, excellent. And this is going to be a great paper for folks to read. Thank you, Todd. It's probably
Thank
time
you.
to move on to our next topic.